Hello, I'm Robbie Mochrie, and today I'm going to talk about part 3 of my textbook, Intermediate Microeconomics, which looks at how firms decide how much output they should produce. In part 2, we reviewed the economic theory of resource allocation, treating people as fully informed, rational consumers. We have developed a method for finding a unique, most preferred, affordable consumption bundle. As part of that process, we derived the condition, which is very important in economics, that if there are two goods in the consumption bundle, then for these goods, the marginal rate of substitution will be equal to the price ratio. That's the core of our theory. In part 3, we will start off by building on what we did in part 2. You should recognise this diagram because it shows the key efficiency conditions for a utility maximising consumers. This is a very natural starting point for what we're going to do. Instead of thinking about people's behaviour, we're going to think about firms' behaviour. Our starting point will be that firms use their resources efficiently. You should see that in moving from the previous slide to this one, all that I have done is to change the labelling. We have already built up a theory in which people use money to buy goods so that they can generate utility. In the same way, we are going to model firms as hiring factor inputs, resources such as capital and labour, and using them to produce goods. We read this diagram as showing an isocost line, which represents all combinations of capital and labour inputs that are equally expensive to hire, and also an isoquant, which shows all combinations of factor inputs that enable the firm to reach a target output. And at point Z, we see the point where the isocost line is tangent to the isoquant. You should not be surprised that this point indicates the combination of inputs which allows the firm to reach its target output at least cost. This is where our analysis of firm behaviour starts to be different from our analysis of individual behaviour. In thinking about firms, we are interested in the cost of production rather than in the demand for factor inputs. You should know this already if you have done an introductory course in microeconomics. Here we are giving some precision to that idea. We define the total cost of producing some level of output as the least possible cost of producing it. If a firm reduces its use of factor inputs, it must reduce production. So firms use inputs in production efficiently. You may well have seen examples of a total cost curve like the one in the diagram. The curve is always upward sloping, getting flatter at low outputs, but then starts to get steeper. In thinking about firm decision making, we do not usually use the total cost of production. Instead, we use two other measures of cost. Average cost is the total cost per unit of output. We define it as the total cost of producing output Q divided by the level of output. Marginal cost is the rate of change of total cost as output increases. We define it as the derivative of total cost with respect to output. Let's see how we obtain average and marginal cost from the total cost curve. I have labelled the tangent to point Y, slope is marginal cost of Y. This is consistent with our definition of marginal functions in part 2, as the rate of change of a variable. Applying the language of calculus, the marginal cost is the derivative of total cost with respect to output. I have also labelled the line connecting the origin to point Y. Slope is average cost of Y. The slope of a line is the distance that we move up per unit that we move to the right. So moving from the origin to Y, the upward movement is the total cost of output Y, and the movement to the right is the level of output Y. Then the slope is the cost per unit of output, or the average cost of output. And because it is very important for our analysis, I've added a second point, Z. The line through the origin is the tangent to Z. Average cost and marginal cost are therefore equal at Z. That turns out to be very important for the firm's long-run decision making. In this slide, you're going to see the kind of relationship between average and marginal costs which we're going to need. The marginal cost curve is U-shaped, so that there is some level of output at which marginal costs are minimised. The average cost curve is also U-shaped, and the marginal cost curve cuts through it at point Z, where the average cost curve is at its minimum. Note that the marginal cost will then be upward sloping. Thinking about these relationships, we will show that when the average cost curve is downward sloping, an increase in the firm's output is going to lead to lower average costs. The more that the firm produces, the lower the cost of producing each unit of output. Since cost reflects the firm's need to hire factor inputs, then if the cost per unit is falling, the firm must be using its factor inputs more productively. We therefore say that the firm enjoys increasing returns to scale. The situation is reversed when the average cost curve is upward sloping, with an increase in output leading to higher average cost. Increasing output will increase the firm's cost per unit, and factor inputs will become less productive. The firm will experience different returns to scale. While costs are important to firms, we expect them to concentrate on making profits. Profits are the difference between the revenue generated from selling output and the firm's costs. You might remember from part 1 that a firm in perfect competition has no market power. That also means that it is a price taker. It must accept the market price. It cannot charge more for its output than its competitors, or else it will make no sales. And we will also see in a moment that it does not want to undercut its competitors. As a price taker, a firm can sell any quantity of output at the market price. Firm revenue is the product of the market price and the firm's output. Since price is constant, total revenue will be proportional to output. So if a firm is a price taker, its total revenue curve will be a line through the origin. You should be able to check that if we think of marginal revenue as the rate of change of total revenue and average revenue as the revenue per unit sold, average and marginal revenue will both be equal to the market price. In this slide, I have put together the total revenue line and the total cost curve. The total cost curve lies above the total revenue line everywhere except at point Z. This means that total costs are greater than total revenue at every level of output except at Z. And at Z, the firm is just breaking even. If this firm is maximising profits, then it is going to produce at Z. It accepts the market price and it sells its output at a price where it breaks even. We can now see why the firm will never undercut the market. If it cuts its price, its total revenue curve will rotate clockwise, but it would then lie below the total cost curve at all levels of output, so the firm is guaranteed to make losses. We can now bring the revenue and the cost curves together. With average cost and average revenue equal, the firm makes zero profits. With marginal revenue equal to marginal cost, we have also found the output where the firm maximises profits. There is more to part 3 than finding the profit maximising output of a firm, but if you understand this presentation well, then everything else should follow on quite naturally from it.